Hello my friends, I hope you guys survived the crazy volatility in Friday's triple witch options thing. So in this video we're going to do something pretty cool. We're going to get historical options data from the polygon.io API, and we're going to do calculate the put call ratio, and we're going to compare Tesla and Nvidia. So at the end we're going to have a plot like this that compares Tesla's put call ratio to Nvidia's put call ratio. So this is part 4 of my polygon.io series. So I recommend you click this link, and I'll put it in the descriptions, and watch my other 3 parts because I talk in depth about how to get started and that sort of thing. This video will be compatible with the free tier, but you're going to have to uncomment certain things to stay within the API calls. But a lot of the things you can get away with not even uncommenting it. Okay, so hopefully you guys will really enjoy the video. Just a few small words on the put call ratio before we get started. It's a measure of sentiment. It's like the more puts to calls, the more like scared people are, and more fear. So it's like a measure of fear and greed. So it's actually part of the CNN's fear and greed index, and has the put and call option ratio. And to be honest, like a lot of times it's measured in terms of open interest, but we don't have open interest data, so we're going to measure it in terms of volume. So it'll be the volume of put options for all contracts for a particular symbol divided by the volume of all call options. So I'll show you how to calculate that, but let's get started. We're going to first show you how to get bar data. So the first things first is, as in my previous videos, we have to pip install the Polygon API client, and I listed the API has the GitHub, and the examples with the REST API is where you should get more info. So okay, so basically you have to install the pip install Polygon API client, and then as in my previous videos I showed you on polygon.io, there's a dashboard. You get your API keys, and if you're using Google Colab, you can put your API key in here. So then you can use Google Colab's user data.get and Polygon API key, or whatever you called it, and then we connect to the polygon.io client by doing client equals REST client, and then my API key. Okay, so let's get started. Let's get started. Okay, so like in my other video, I showed you how to get bar data for stocks. So for options, it's actually pretty much the same thing, except the ticker is the option ticker. So a ticker would look something like this, whereas like underlying symbols, things related to the date and the call price, and what type of, in the option price, if it's a call put, and that sort of thing. And I'll show you how to map that to if it's a call put and that sort of thing, like in an easier way. Later in this video, but let's get started by showing you basically if you have the unique identifier of the contract, how you can get the data. And note, this is better than interactive brokers because you can get expired data, and interactive brokers you can't get data for expired contracts. Okay, so first thing I want to show you the simplest way. So so the simplest way is, by the way, you use client.list_ags as in the previous video, but the simplest thing is if you don't worry about rate limits, like let's say you have a premium account, or you're getting not that much data, then you don't really have to worry about anything. You can literally just do df equals pd.dataframe, and then you do client.list_ags. And in list ags, you have the ticker, and the ticker is that symbol above we had. So it was this thing. So it's almost the exact same as the stock thing. And then after that, you put the multiplier, which is if you want 5-minute bars, it'll be equals 5. And then you do the time span, which is the bar if it's a week or day, that sort of thing. We'll do 1 minute, so we do minute. So we have 5-minute bars, and then we have from, which is like the earliest time for the bar. So let's do 2024, 03, 01 or something like that. And then 2 is the last day of the bar. So 2025, 01, 01, that's in the future. And then this is important, especially if you have the free account, is you do limit equals, there's like each thing has a limit. So if you see, let's actually show you guys, if you do like help client dot list ags, if you do that, you see that there's a limit parameter. So each API call you get up to, the max is 50,000, but by default is 5,000. So each API call you can get 50,000. But if you're limited to 5 because you have the free account, you should always set it to the max. So let's use that practice. So I wrote max bar limit is 50,000, and then I can do limit equals max bar limit, and now I get that. And by the way, this is an iterator, but you can create a data frame from an iterator. And since this is less than the max limit, plus I have the premium account, it'll work straight like this. I get a data frame, open, high, low, close, volume, VWAP, timestamp. The timestamp isn't in the most beautiful format. So in my other videos, and you'll see that the Google's nice AI knows what I want it to do. I can convert it to this timestamp format by doing PD.do to datetime, unit is microseconds, and I get the data frame. Okay, and you see the timestamp is nice. Okay, but like, look, if you have the free tier and you're gonna get a bigger data set than this data set, you're gonna have to pause every 5 API calls. So let me show you guys how one way to do that. So we would do, and this probably is best practice the rest of the way. So I'm gonna keep things in this format where I'm going to basically basically like sleep every 5 API calls. So I do option bars empty list, and what happens is I iterate through the call of client that list ags, and each time it gives me one element. But an API call is after you get that full 50,000 or until the data is over. So I do for bar in client that list ags, and then I do ticker equals, let's see if it remembers. Nope. So let's copy and paste this ticker. Okay, so I copied and pasted the ticker. It's like this guy. Multiplier, let's do 1 minute. Let me do second, okay? The free account doesn't have second, but I want to illustrate a point. So because the free account has only maximum of 5 API calls a minute, so basically, let's import time here. Import time. So if length of option bars mod 5 times max bar limit, if this thing equals 0, meaning you've done 5 API calls, we're going to sleep for 60 seconds. And so maybe I'll write something like print getting data for what the autocomplete's not doing it right. Print sleeping for 60 seconds and then I'll write print done sleeping. Okay, let's see if this works. So it's kind of a hard to understand concepts. Even though you have 5 API calls, it's an iterator, so it does one at a time. But only when you get to 50,000 in this, 50,000 it counts as one call. But because the data is actually small, this was meaningless. So let me set it back to minute so it'll work for your free accounts also. So okay, so now you get option bars like this, but like it's good to have this just in case you have the free account. So option bars, by the way, if you don't make it a data frame, looks like this, has open, high, low, close, volume, timestamp. So of course you can make it a data frame by doing pd.data frame option bars, and I do .head to get the first view, and you see it's like above. Okay, so now this is a really cool method. Like, what if you want the options chain, or you want to know all the contracts that have been around in the past? So you can actually do that, and this is a little bit different than interactive brokers because here you can get the active contracts and also the expired contracts. So I'll show you how to do that here, and we're going to use this client.list options contracts method for this. So let me show you guys how to do that. And what I found is they give you distinct ones if you filter for expired or not. So let's do that. And first, let me talk about some of the options. So let me do help client dot list. What's it called? List options contracts. So you see you have like the underlying ticker. By the way, you can make more than one ticker. You can have a ticker between this and that. So if you want, like, you can. So this is where you would need to do the time.sleep if you have the free account, because let's say you want it for like every ticker, and the max limit here is 1,000. 5,000 it won't be enough, so you're gonna need that. So anyways, this is the video. I'm not gonna go into too much detail about these things because this is more of just to give you a flavor and to show you how to calculate the put call ratio. But you have expiration date. You have all these filters like expiration date less than or equal to, expiration date greater than, expiration date itself equals. You have strike price less than or equal to, strike price greater than or equal to, strike price equal to. So you can filter a lot of things, which is really cool. So let me show you guys how we might use that. And so let's just show you how to do that, because I want to calculate the put call ratio for Rivian, because I lose a lot of money on Rivian from June. Okay, so let's do underlying stock equals Rivian. Okay, and then let's pick a start date, which we want our expirations from that start date. So let's do it from June. So we'll do start date equals 2024 0601. And now we're going to get the active contracts. So active contracts are the ones that are still not expired. So active contracts, wow, the Google remembers what I did. So so I do for option in client that list option contracts, underlying ticker equals underlying stock, expiration date greater than or equal to start date, and then limit equals 1,000. That's the max. And let me also write this. And oh, it's crazy. Google remembers what I wrote when I was practicing for this video. I wrote like uncomment both lines below if you're using the free tier. So if you're using the free tier, basically every 5,000 elements, which is 5 API calls, because 5 times 1,000, you're going to sleep for 60 seconds. So you can use this with the free tier. So now you get the active contracts. To show you guys how the active contracts looks, we can use the first couple. Wow, this autocomplete AI thing is really cool. So you see these are the first couple. What's interesting is you get contract type, expiration date. It has also like the ticker, that's the unique identifier, strike price, and other things like what type of option, what's the primary exchange. But we mainly, between me and you, we only care about the expiration date, the contract type, the strike, and the ticker unique identifier, and the underlying ticker. Okay, so this is the active contracts. If you want expired contracts, you would do something very similar, but but there's expired equals true. So I did the exact same thing as above, but expired equals true. So I do that, and then let's show you, and then we can do the uncomment thing here. All right, AI didn't get, I guess the AI wasn't smart enough this time. So if you have the demo account, just uncomment here. Oh, now it woke up. Okay, so if you have the demo account, uncomment here below. Not demo, the free tier. Now you get the expired contracts. It looks the exact same thing. It looks exactly the same. Okay, so I just wanted to note that they don't have any overlap between the two, the expired and active. And how can we do that? We can do we can look at the ticker, which is the unique identifier. So I can do contract dot ticker for contract in active contracts, and then I can do contract dot ticker for contract and expired contracts. It's funny, I'm a pandas person. I use pandas for everything. So I don't know why I'm doing it with sets, but anyways, we make these two lists a set, and then we use the intersection method. And so I found all the unique tickers in the active contracts and all the unique tickers in the expired contracts. By the way, there is no duplicates, but just so I can use the intersection method, I made it a set, and look, I get the empty set because they have nothing in common. And just for the hell of it, you can look at the length of the two. active contracts and expired contracts. And because we're only doing it from June 1, there are definitely more active contracts than expired contracts. Okay, so now let's combine the two and make it one list. So we're gonna combine the two and make it one list. We'll just call it options contracts equals expired contracts plus active contracts. Okay. So now that we have our options contracts, which is, let me just show you how it looks like if you're interested. Options contracts. We have our options contracts. Options contracts. Wait, no. Contracts. Huh? My spelling is off somewhere. Oh, okay. I guess I didn't hit enter. Okay, so you see like this how it looks like in a data frame format. So what we're gonna do is we're gonna go through all the tickers, the unique tickers, and we're gonna get the daily bar data from June 1st for those tickers because I want to do the put call ratio for June 1st. So let's so we're gonna get the daily bar data from June 1st for each of these tickers, and so it will have a list of data frames. Since I'm going to assume you have the free version, I'm going to add the sleep every 5 API calls. And then once we have the list of data frames, once we iterated through all the tickers, we're going to do pd.concat. And then we get one data frame with everything. And just one quick thing is I'm going to use the pandas assign method. I'll show you in a second. So if you guys are not familiar, pandas assign, you can do assign new call equals my new call. You can do this. So as you see at the end, it adds new call. I'm going to do that because we're going to need to have the ticker in there so we can join it later with this table to get like if it's a call or a put and that sort of thing. Okay, so let's show you guys how to do that. So we're going to do like DFList, like a data frame list, and we're going to iterate through. We're going to do for contract in options contracts, and then we're going to DFList dot append. And then, by the way, I'm not. I'm just doing it as the first example directly from a data frame as into data frame because I'm using daily data and it's way less than 50,000. So we don't have to worry about like limits and that sort of thing. So our time span, we want daily data, I think. That's what we don't, weekly data would be kind of boring. Start date, we defined above as June 1st. And so we're going to do this list ags. We're going to get contract that ticker, gives us the unique option ticker. And then I do a dot assign, ticker equals contract that ticker, which I'm going to need later to join with this table so I can get if it's a call or a put. So, and then once I'm done with this loop, and by the way, as I have here, I'm going to uncomment these two lines if I have the free version. So basically, every 5 calls, so when list of this, when df.list mod 5 equals 0, so 5 calls, I'm going to sleep for 60 seconds. Okay, so yeah, so that's what we're going to do. And then you get DFList. You know, I'll do it in 2 steps. So we're going to get this DFList. It might not be instantaneous. If you do threading and you have the non-demo account, not non-free account, it can be much faster. But okay, but the end you're going to do a df.pd.concat DFList, and let me just show you first how DFList looks like. We can look at the first element, and we'll do .head, and then I'll also do length of DFList while it's running. So let's wait until it's running, and then let's do that. The market is starting very soon, so hopefully this will be done soon. Although my #1 rule is never make manual trades, because I just lose every single time I make a manual trade. Anyways, still running. I guess it has to do this many calls, so it might take a little bit of time. While you're at it, if this gives you guys value, please like and subscribe. It makes me very happy. And Google's algorithm kind of hates me. It likes LLM videos a lot more than this polygon stuff, but I want it to be the opposite because I like the finance stuff. So hopefully these videos will get some traction. So while this thing is waiting, eventually I'm going to have a data frame. And I wrote the note here, concatenate the data frames into a large data frame here. So that's with pd.concat. So once this is done, you'll see that. And then remember, like in the beginning, I showed you the timestamp is a little bit of a weird format. So we want to convert it to a pandas datetime format. So it'll be pd.toDatetime, df timestamp, unit is microseconds. Oh man, when is this going to finish? I think for my practice example, I used Faraday futures because my friend wanted me to check that, and it was much faster. I started from 6.1. Yeah, it should work. Come on, I should have did it like a timer. Sorry, awkward pause. Okay. Like and subscribe. I guess that's the only thing I can do in the meantime. Yeah. I guess, okay, while this is running, I just want to maybe illustrate. And by the way, watch my other Polygon.io videos. This is kind of an interesting graph. So at the beginning of the year, like there was a lot more puts than calls on Tesla. And then I guess Tesla went really down after the earnings. And then there was a lot more... it went really down after like right after the earnings, right after like I think the first before the first deliveries, I guess. But what's interesting here is Tesla's way higher. The put call ratio is way higher for Tesla, but now all of a sudden things look a little bit better for Tesla. They had a decent earnings call and that sort of thing. And then now it's actually some days it's actually a lower put call ratio than Nvidia, which is funny because Nvidia is like Wall Street's darling. Why is this not finishing? Probably should cut some of this out. Sorry, awkward silence. Okay, great, it finished. Sorry about the awkward silence. So if you do df.head of the first element in the list, you get the ticker, you get the timestamp, the volume, that sort of thing, open, high, low, close volume. You do length of this, you get 992. And now we can concatenate the data frames into one giant data frame. And by the way, the sign thing here was necessary because it gave me ticker and then the ticker value. So I get one big data frame by doing pd.concat. And then, like I said previously, make the timestamp nicer. And now we want to combine the bars with the contracts to get like the contract type. So let me show you guys how to do that. Just show you guys first of all how the contracts looks like. We actually did it up here where we did options contracts. We did it like oh, it's funny, I gave you the answer here. Look, we did it up here. These are the option contracts without this assign thing. Okay, and we want to combine this with the data frame we just created. So we're going to use pandas merge, and we're going to merge on ticker, and we're going to create our new data frame. So our new data frame is here, data frame, df. Okay, so now that we have df, what are we going to do? So this is going to be a data frame, and the most important thing we need here is we need, I guess, timestamp. We're going to need a contract type. We're going to need volume. And we're going to need, I think that's all we need, right? Okay, so that's all we need. So now let's compute the put call volume ratio. So you know what? Let's do it. There's many ways to do this. Okay, so call volume, and the AI is amazing. Look how fast it did it. The call volume, I do call volume. I do when contract is call, it's the volume column. Otherwise, it's 0. When for put volume, one contract type is put. Otherwise, volume, it's the volume. Otherwise, it's 0. You can also do .apply with pandas, but I guess I did it like with NumPy in my previous thing. So now we want to group by timestamp, and we want to sum up the put volume, call volume, and I guess we can sum up the total volume. So I call it DF grouped. And then the put call ratio is just the ratio of the put volume to the call volume. And again, this thing is often computed with open interest and not volume. So now you can use Plotly to plot it over time. So I guess if enough people comment, I'll make a Plotly video. So I do px that line, df grouped. Because your index is this column, you don't have to write x equals, but then you do y equals put call ratio, and then you get the height and the width. And then, so this you get the put call ratio of Rivian over time. And it's actually interesting because Rivian did crash kind of here. So it interestingly makes sense. Here I just kind of show you guys, if you're interested, how to get the put call ratio for Tesla and NVIDIA from year to date. This example is going to be compatible with the free tier, where I pause, if you uncomment, it pauses. So the thing is, and so this will just be a function that'll give you put call ratio. And then I have a multi-threading version because that took way too long, especially for NVIDIA and Tesla because they have a lot of options contract. So the multi-threading version was much faster. So I got the put call ratio for Tesla and NVIDIA. I combined them by doing .concat. Again, I do a sign, ticker NVIDIA and ticker Tesla. And each of these returns like the grouped version, like the put call ratio. And then I plotted the two, and I made it thick so it can be in my YouTube thumbnail. Anyways, hope you guys enjoyed this video. Sorry for the pause. Please like and subscribe, and good luck trading if you do trade.